Good morning, everyone. So I think we have completed up to biological systems. After that lesson, we have to do about acid base and neutralization reaction, that lesson. But I think it is better to do that lesson with you because that involves some practical sessions, laboratory practical sessions. So I hope to do the next lesson. That means the heat changes associated with chemical reactions, and also the next lesson. After this lesson, we have the next lesson like heat, right? It is in the part 2. So these two lessons are connected with each other. So I hope to do both lessons. Okay. So actually this heat changes associated with chemical reactions. This comes under physical chemistry lesson, right? So we will do this heat changes associated with chemical reaction in small lesson, and then the next lesson about heat. Okay, children. This lesson includes reactions, right? But you have learned about reactions when you were in grade 10, right? But actually when you have learned about the reactions, you have learned only the chemical changes, what is happening there inside the reaction, what are the chemical changes, what are the observations, right? What are the conclusions, like these things you have learned. But in this lesson, I told you during the introduction part that this lesson comes under physical chemistry. So in this lesson, we are not going to talk about the observations, right, which are happening during the reaction. But in this lesson, we are going to talk about the heat. The emission of heat occurs during the reaction, right? After this, we are going to calculate the amount of heat emerged or emitted during the reaction. Okay, so actually during reaction, you have experienced this thing, right? In your grade 10, we have done this practical, right? If we put magnesium strip into a test tube containing HCl, right? Just assume that this test tube containing dilute HCl. Okay. If we put magnesium strip, small magnesium strip, into this test tube, right, you will see some emission of gases and all. But as I mentioned earlier, we are not going to talk about these things, emission of gas or the color changes or whatever. We are not going to talk. Here you have experienced, you have felt, I think, the temperature of this medium, temperature of this test tube get increased, right, during this reaction, right? Simply, if I say, if you touch the surface of the test tube, you may have experienced that you felt a very hot feeling at the outer surface of the test tube. Okay, that means the temperature of this medium has been risen, right? So, what is the reason for this increasing temperature? Because during this reaction, during this process, the heat should be released to the environment. That is why the temperature was increased. Okay. So, if I write this reaction, you have already learned how to write reactions. Magnesium solid plus HCl equals, what are the results? Magnesium chloride and hydrogen gas. Okay. So, during this reaction, the heat should be released to the environment. That is why the temperature of the medium or temperature of the test tube, right, get increased. So, heat is released. Right. During this lesson, we are going to talk about this heat, amount of which are released during these reactions. Okay, so you have experienced this kind of things when we do our practicals. Okay. At the same time, right, for some reactions, you know that heat should be absorbed by the reactants, by these chemicals, in order to occur the reaction. For an example, you have heard about limestone. Limestone means calcium carbonate. Calcium carbonate. Right. Calcium carbonate, limestone. Right. The dissociation of calcium carbonate does not occur naturally or automatically. Right. So if we provide heat to the limestone, they get dissociated. Okay, like this. For this reaction, in order to occur this reaction, we have to provide heat. Right? Heat, we have to provide heat. Right? The heat which are provided to the medium is being absorbed to the calcium carbonate. Right? To produce calcium oxide and carbon dioxide. Okay. So, this reaction needs to absorb heat, whereas this reaction release heat. Okay. You can understand some reactions need heat, right? They need heat to be absorbed to the medium in order to happen, and some reactions release heat during the reaction. Okay. So now, according to this, you can understand that there are two types of reactions, right? According to the emission or absorption of heat. Right? Some reactions releases heat, and these are called exothermic reactions. Right? Some reactions absorb heat. They are called endothermic reactions. So there are two types of reactions: exothermic reactions and endothermic. Now let us discuss some examples under exothermic and endothermic reactions. Right? As I mentioned earlier, magnesium HCl reaction. Right? Not only magnesium but the other metals, sodium, maybe aluminium, right? And the HCl, like acids reaction. That means metal acid reactions, right? They release heat energy during the reaction, right? They comes under exothermic reactions, and also acid-base reactions, right? That means sodium hydroxide, for an example, sodium hydroxide, right? Maybe magnesium hydroxide, right? These kind of bases, if when they react with acids, right, these reactions release heat energy, right? So they are exothermic reactions, right? And also, if you dissolve calcium oxide with water, right, to produce slate line like calcium hydroxide, right, they are also comes under exothermic reactions, right? So I have given you some examples for exothermic reactions, and also another example. So when you dissolve sodium or magnesium in water, right, that is also exothermic reaction, right? When metal dissolve in water, they release energy, heat energy. So when we go to the endothermic reactions, as I mentioned earlier, dissociation of calcium carbonate, dissociation of limestone, they release, so they absorb energy, so they come under endothermic reactions, right? And also, I think you have learned about photosynthesis, right? During the photosynthesis, it is also a chemical reaction, right? What happens during the photosynthesis? Carbon dioxide react with water to produce glucose. Okay. This reaction needs heat energy, right? That is what the chlorophyll absorb heat energy, right? The plant leaves absorb heat energy, light, right? In order to happen this reaction. So this photosynthetic reaction comes under endothermic reaction. So there are some examples for endothermic reactions, right? And then we are going to talk about the most important part of the lesson. That is, you have to understand and calculate the heat energy released or absorbed during the reactions, right? Before going to that part, I want to teach you the important part, that is to draw energy level diagrams or enthalpy diagrams, right? Let us consider about this reaction, right? Magnesium HCl, magnesium reacts with HCl, forming magnesium chloride and hydrogen gas. So I think you have learned about these terms, right? Magnesium and HCl, they are called reactants, right? Magnesium chloride and hydrogen, they are called products. Okay. So when you are going to draw an enthalpy diagram or energy level diagram, you should know these terms, right? First, we are going to this graph, right? This is called an enthalpy or energy level diagram. There you have to mention this column as energy, right? So, if you think about this magnesium and HCl, the reactants, right? During this reaction, magnesium and HCl convert into magnesium chloride and hydrogen. Okay? So, during this reaction, heat is released. Heat is an energy. So, that energy is released during this reaction. So, the amount of energy, right? The amount of energy of these products, right? The amount of energy of the product is lower than that of reactants. Why? Some amount of energy has been released to the environment during this reaction. Some amount of energy which were inside these reactants have been released to the environment. Now the energy of the products are lower than that of reactants. Okay? So, if you go to this diagram, right, the energy of the products, right, it is in a lower level, it should be in a lower level than reactants, right? The reactants, they are magnesium and HCl, products, magnesium chloride and hydrogen, right? The energy of the product is lower than reactants. Okay, and you have to show the releasing energy like this, right? Heat energy, and you have to show that this decreasing energy during this process from an arrow. This arrow is indicated the decreasing energy, right? So, and also sometimes this heat energy is written as delta H, right? You can write this as delta H, right? This is for the exothermic reaction, because this is an exothermic reaction as the heat is released, right? So this is an enthalpy diagram or energy level diagram for exothermic reaction. And another important thing, when you write these reactants, right, it is important, it is necessary to write the physical state of the particular chemical, right? I think I have told you in your grade 10, I have told you that it is not very important for your level, it is not very important to write the physical state of the reactants every time, but here it is very important to write the physical state, and it is a must to write the physical state. Magnesium, it is in the solid state, HCl aqueous, magnesium chloride aqueous and hydrogen gas. Okay. This is for the exothermic reaction. Now let us consider an endothermic reaction, right? carbonate and form calcium oxide solid and carbon dioxide gas. So, when you draw the enthalpy or energy level diagram for this reaction, you know that another extra energy is absorbed by the calcium carbonate to form calcium oxide and carbon dioxide. That means the amount of energy, right? Amount of energy in the calcium carbonate, right? When it becomes calcium oxide and carbon dioxide, they contain more energy. Calcium oxide and calcium carbonate, the products has got more energy than that of calcium carbonate because the calcium carbonate has already absorbed extra energy. So the energy of the product is higher than reactants. Reactant is a calcium carbonate. That the product energy, calcium oxide and carbon dioxide energy, that energy is higher than calcium carbonate, right? So the reactants, the energy of the reactants, it is at the lower level. Energy of the product is at the higher level. That increasing energy is indicated by this arrow, right? This arrow should be the upward direction, right? And also you have to show that the heat is absorbed by this process. Okay. This is for an energy level diagram of an endothermic reaction.